We've decided the best way to explain ThermaDeck is to actually get out on the job site and watch it be put together. So let's just get up on the roof. So we can take a closer look at the ThermaDeck. I've had the guys remove one sheet of the plywood so we can see how it all goes together. Heat travels three different ways: conduction, convection, and radiation. ThermaDeck is the only product that stops all three. The first thing we stop is the radiant heat. The aluminum reflects about 97% of your radiant heat. It's reflected right back where it comes from. The second way we stop the heat from getting in the attic is we've got a 1-inch polystyrene, which is going to have about a R5 insulation. So it's very difficult for any heat to be conducted through into the attic. And the third point is the convection currents. We use the convection currents to our advantage. The way ThermaDeck uses convection to its advantage is what puts it all together. What we've created here with the decking on top of the ThermaDeck is created a 1-inch airspace. The next step is we're going to be putting a composition roof on top of that. And what's going to actually happen? The sun's going to come out, it's going to heat up the composition roof. The composition roof is in turn going to heat up the decking. The decking is going to heat up the air adjacent to it, and it's going to cause that air to rise going up toward the vented ridge. An additional thing is happening here is the radiant heat's going to go through the composition roof and the decking, and normally would accumulate in the attic. But in this case, we reflected it back where it's coming from, so it's not going to reach the attic. Another real benefit of the aluminum, it actually heats up from the radiant heat, but it dissipates it instantly. So what we have now is a polystyrene, 1-inch polystyrene, which is going to give us an R5. So now we're going to stop the conduction of heat into the attic. Now at the bottom here, you notice we've cut a hole so that we can draw cool air from the soffit, because as this warm air is rising, something's got to replace it. So we're going to pull the cool air in from the soffit area, which is, by the way, the coolest area we have. It's going to be about 5–10 degrees cooler underneath the soffit than it is out, just ambient temperature. So we're drawing the cool air in here. The heated air is actually pulling it on with it and going out the ridge. The key to the ThermaDeck working is actually making cold air rise. Well, I get the question, how do you make cold air rise? Well, the way you do it is you heat up the air above it, and that's done by just the radiant heat heating up the decking, heating up the composition roofing, and heating up the air in the 1-inch airspace. It just is going to naturally rise. And that creates a siphon effect, which draws the cool air in from the soffit, and then expels it through the vented ridge. As you can see, we're about to wrap it up here, and the composition roof just looks like everybody else's roof up and down the street here. We know that it's not permanent. We know it's going to have to be replaced after a few years, but the ThermaDeck is permanent, and so is the savings that go along with it.